Welcome back, my dear students. In the last session, we have finished chapter number 11, mensuration. In this session, let us learn chapter number 12, exponents and powers. Chapter number 12, exponents and power. Chapter number 12, exponent and power. Here is 16. 16 we can write as 2 into 2 into 2 into 2. Here 2 is multiplying 4 times, so this is equal to 2 to the power 4. Here this number 2 is called exponents or power. Exponents or power. And this number 2 is called base. Base. Now let's learn laws of exponents. Number 1, a to the power m into a to the power n is equal to a to the power m plus n. If a to the power m is multiplied by a power n, this is multiply, we will add the powers, so a plus n. Now law number 2, a to the power m divided by a power n, then a to the power m minus n. So from this m we have to subtract this power n. Next, law number 3, a to the power m whole to the power n. If we leave this bracket, then these two powers m and n will multiply. That means a to the power m n. Now law number 4, a to the power m into b power m. Here base are different. Here base a, here base is b, but the powers are same. Here power is m, here power is m. Then we can take the same power common. So m is taking common, then we are getting ab whole to the power m. Power m is taking common. Now law number 5, a to the power m divided by b power m. Here the base are different, but the power are same. So this same power we are taking common. That means a by b whole to the power m. Now law number 6, a to the power 0 is equal to 1. Now how this a power 0 is equal to 1, let us see. We know that a power to the power 0 we can write as a to the power 1 minus 1. If from this one, if we subtract 1, then we'll get 0. So a power 0 is equal to a to the power 1 minus 1. Next, a to the power 1, if there is minus sign, if we use this law number 2, we can write as a to the power 1 is divided by a to the power 1. Then if there is power 1, we are not used to keep the power, so a divided by a. If a is divided by a, then we are getting 1. So therefore a to the power 0 is equal to 1. So law number 6, a to the power 0 is equal to 1 is getting. Next is, if there is minus sign in the power a to the power minus 1, then this minus 1 we can write as 0 minus 1. Then a to the power 0 divided by a power 1, this is law number 2. This law number 2. So a to the power 0 divided by a, then by law number 6, a to the power 0 is equal to 1. So a power 0 is 1, then 1 by a is getting, therefore a to the power minus 1 is equal to 1 by a. So a to the power minus 1 is equal to 1 by a. If in the power there is minus sign, then we have to leave this minus sign, then we have to write on 1 by a. So a to the power minus 3 is equal to, if there is minus sign in the power, this minus sign, then we have to leave this minus sign, then we can write 1 by a cube. This power 3 is here, but this minus sign from the power is leaving, then we are writing 1 by a cube using this step. Then next, now after learning this laws of exponent, now we can try exercise. Now let us start exercise 12.1. 12.1, question number 1, evaluate Roman number 1, 3 to the power minus 2. Solution. 3 to the power minus 2 is equal to, now according to this rule, a to the power minus 3 is equal to 1 by a square. We can write this 3 to the power minus 2 is 1 by 3 square is equal to sine 1 by 3 square is 3 times 3, that is 1 by 9. So 1 by 9 is the answer. Roman number 2 is same, so you try this Roman number 2. Now let's try this Roman number 3. Roman number 3 is solution. 1 by 2 whole to the power minus 5 is equal to sine. If there is minus sign in the power, we can write as 1 by 2 whole to the power 5. Now next steps. This number 1 you write here, and this line means divides. 1 by 2 whole to the power 5 is equal to 1 is divided by, now 1 to the power 5 again 2 to the power 5 is equal to sine 1 divided by 1 to the power 5 is 1 into 1 into 1 into 1 into 1, that is 5. 2 to the power 5 is 2 into 2 into 2 into 2 into 2, 1 2 3 4 5. Then next is equal to 1 is divided by 5 by 2 times 2 is 4, 4 2 times is 8, 8 2 times is 16, 16 2 times is 32. So we are getting this 5 by 32. Now is equal to 1. If this divide is changed into multiply, 5 and 32 are interchanged, then 32 will come up and 5 is in the denominator. Then we are getting 32 by 5, and this is the answer. Here I make one mistake. 1 to the power 5 means 1 into 1 into 1 into 1 into 1 into 1. 1 2 3 4 5. 1 times 1 is 1 into 1 is 1 into 1 is 1 into 1 is 1. So this must be 1. So 1. Then means this must be 1. 1 by 32. If 1 by 32 are interchanged, that is 32 by 1. This is 1. Then 32 by 1. 1 is leaving, then we'll get 32. So 32 is the answer. So 32 is the answer. 1 into 32 by 1 is, now this one and this one we can leave, then this 32 is here, so 32 is the answer. Then next let's try question number 2. Question number 2 here. Let's study the question. Simplify and express the result in power notation with positive exponent. Okay, now let's try this Roman number 1. Now solution. Minus 4 to the power 5 is divided by minus 4 to the power 8. Now is equal to minus 4 to the power, you see this is divide. So if we use loss of exponent, if there is divide, we'll subtract the power. So here the power is 5, then minus 8 is equal to sine minus 4 to the power 5 minus 8 is 5 6 7 minus 3. If there is minus in the power, we'll write 1 by minus 4 to the power 3. Next is 1 by minus 4 to the power 3 is minus 4 into minus 4 into minus 4. Is equal to sine 1 by minus into minus is plus, plus into minus is minus, so minus 4 times 4 is 16, 16 4 times is 64, so we are getting this. And we are not used to keep minus in the denominator, so this minus keep in the numerator. Then we are getting minus 1 by 64, and this is the answer. Okay, you see this question once. Simplify and express the result in power notation with positive exponent. Here the question says that the last answer you have to write down in power notation, and we have to keep positive power. Exponent means power, so these steps is no need. So we have to write down in the power notation. So here we are getting 1 by minus 4 to the power 3. So here this question is over and this is the answer. Then Roman number 2 and 3 are same, so you try this 2 and 3. Now let's try this Roman number 4. 3 to the power minus 7 divided by 3 to the power minus 10 whole into 3 to the power minus 5. Okay, let's try this question. Now solution. 3 to the power minus 7 divided by 3 to the power minus 10 whole into 3 to the power minus 5. We have to finish the bracket first. So let's try to finish this bracket first. Here is divide. So if there is divide, if we use the loss of exponent, then we will subtract the power. So 3 to the power minus 7, then minus this power will come minus 10, then into 3 to the power minus 5. Okay, here use one bracket. 3 to the power, write this minus 7. If we leave this bracket, minus 2 minus is plus, so plus 10, then bracket into 3 to the power minus 5. Next, 3 to the power, here is minus, here is plus. If the sign are different, we have to subtract. From 10, if we subtract 7, then we are getting 3. 3 power 3 into 3 to the power minus 5. Now next step. And you see this is into 3 to the power 3 into, if there is minus in the power, then we have to write down 1 by 3 to the power 5. Next is, if 3 to the power 3 and this one are multiplied, then we'll get 3 to the power 3, then here is 3 to the power 5. Then 3 to the power 3 we can write as 3 into 3 into 3. 3 to the power 5 we can write as 3 into 3 into 3 into 3 into 3. So this 3 divide 3 one times, this 3 divide 3 one times, this 3 divide 3 one times. Next is 1 into 1 into 1 is 1. 3 is multiplied by 3, then there is 3 square. And this is the answer. Now let's try question number 3. Find the value of Roman number 1, 3 to the power 0 plus 4 to the power minus 1 into 2 square. Now solution. 3 to the power 0 plus 4 to the power minus 1 into 2 square. Three to the power 0 is 1. Since a to the power 0 is 1, then next is plus. If there is minus in the power, we have to write down 1 by 4. Then bracket into 2 square. 2 square is 2 into 2. Here let's add together 1 plus 1 by 4. If we take LCM the denominator, then we will get 4. Here is 1. 1 divide 4, that is 4 times 4 into 1 is 4. So 4 plus 1. If 2 and 2 are multiplied, then we are getting 4. 4 plus 1 is 5. Then in the denominator 4 into 4. If 4 and 4 are cancelled, then we are getting 5. And this 5 is the answer. Roman number 2 is same, so you try Roman number 2. Now let's try 3. Roman number 3. Now solution. Half to the power minus 2 plus 1 by 3 whole to the power minus 2 plus 1 by 4 whole to the power minus 2. Next steps. Here let us use shortcut. If there is minus sign in the power, this numerator and denominator we can interchange. That means minus sign is leaving from the power, 1 and 2 are interchanged, then we can write 2 by 1 whole square plus here minus sign in the power, so let's leave this minus sign, and 1 and 3 are interchanged, then we can write 3 by 1 whole square plus here there is minus sign in the power, so 1 and 4 are interchanged, then we'll get 4 by 1 whole to the power 2. Now next steps. 2 square is 4, 3 square is 3 into 3, that is 9, 4 square is 4 times 4, that is 16. Now let us add together. 16 plus 4 is 20, 20 plus 9 is 29, so we are getting 29. And this 29 is the answer. Roman number 4 is same, so you try Roman number 4. Now let's try Roman number 5. Roman number 5. Now solution. Minus 2 by 3 whole to the power minus 2 whole square. First let's leave this second bracket. Minus 2 by 3 whole to the power. If we leave this second bracket, minus 2 and 2 will be multiplied. Minus 2 into 2. Minus 2 by 3 whole to the power. If minus 2 and 2 are multiplied, then we will get minus 4. If there is minus in the power, numerator and denominator will be interchanged. Then 3, this denominator 3 will come up to the numerator and minus 2 will come down in the denominator. Then whole to the power this 4. Then next steps. 3 to the power 4 means 3 into 3 into 3 into 3. Minus 2 to the power 4 means minus 2 into minus 2 into minus 2 into minus 2. Now let us multiply this. 3 times 3 is 9, 9, 3 times is 27, 27, 3 times is 81. Now let us multiply this. First let us see minus sign. Minus into minus is plus, minus into minus is plus, so now plus sign. 2 times 2 is 4, 4 2 times is 8, 8 2 times is 16, so we are getting 81 by 16. And this is the answer. Next, let's try question number 4. Evaluate Roman number 1 is same as Roman number 2, so let's try this Roman number 2. 5 to the power minus 1 into 2 to the power minus 1 into 6 to the power minus 1. Now solution. 5 to the power minus 1 into 2 to the power minus 1 into 6 to the power minus 1. Now next steps. If there is minus sign in the power, then we'll leave a minus sign from the power, then we will write 1 by 5. Here is minus sign in the power, so we are leaving minus sign from the power, then we can write 1 by 2 into, here is also minus sign in the power, so we can leave this minus sign and we can write as 1 by 6. Now next steps. Let's finish the bracket first. 1 times 1 is 1, 5 times 2 is 10, then into 1 by 6. Next is equal to sign. This is multiply. 1 times 1 is 1, 10, 6 times is 60. So 1 by 60 is the answer. See, yani ko bhab tare ko. Next, let's try this question number 5. Let's study the question. Find the value of m for which 5 to the power m divided by 5 to the power minus 3 is equal to 5 to the power 5. In this question, it says that to find out the value of m, and it is given that 5 to the power m divided by 5 to the power minus 3 is equal to 5 to the power 5. Okay, now let's try. Now solution. Solution. So write this now. 5 to the power m is divided by 5 to the power minus 3. This is equal to 5 to the power 5. Okay, now next steps. If there is minus sign, if there is divide, then according to the laws of exponent, we have to subtract the power. So 5, here is power m. Since there is divide, we have to subtract. Since there is minus 3, so we have to write on minus 3 like this. 5 to the power m minus, then minus 3 is equal to 5 to the power 5. Then next steps. 5 to the power m. If we are leaving this bracket, minus and minus are multiplied, then we are getting plus 3 is equal to 5 to the power 5. Here base are equal. This is also 5, this is also 5. So base are cancel. Then we can write as m plus 3 is equal to this 5. Therefore m is equal to, if plus 3 is transposing to the other side, plus sign is changed to minus, so we are getting 5 minus 3. Then if we are subtracting 3 from 5, then we are getting 2. So this 2 is the answer. Now let's try this question number 6. Let's study the question. Evaluate Roman number 1, 1 by 3 whole to the power minus 1 minus 1 by 4 whole to the power minus 1 whole to the power minus 1. Now solution. Now bracket 1 by 3 whole to the power minus 1 minus 1 by 4 whole to the power minus 1 again whole to the power minus 1. Now next steps. If there is minus sign in the power, now this 1 and 3 we can interchange the numerator and denominator, then we can write as 3 by 1 minus, if there is minus sign in the power, we can leave this minus sign from the power, then 1 and 4 are interchanged, then we can write as 4 by 1, and again here is power minus 1. And then next steps. 3 by 1 is same as 3 minus 4 by 1 is same as 4 whole to the power minus 1. 3 minus 4 is minus 1, now whole to the power minus 1. If there is minus in the power, then we can write 1 by minus 1 whole to the power 1. Then if 1 divide 1, we will get 1, then here is minus sign, so we are getting minus 1. And this is the answer. Minus 1 is the answer. Next, let's try Roman number 2 is same, so you try this Roman number 2. Now let's try this question number 7. Simplify. Simplify Roman number 1. 25 into t to the power minus 4 divided by 5 to the power minus 3 into 10 into t to the power minus 8. T is not equal to 0. Now solution. Let's copy the question. 25 into t to the power minus 4 by 5 to the power minus 3 into 10 into t to the power minus 8. Next steps. This 25 keep here into t to the power minus 4. Then this 5 to the power minus 3 we can write as 1 by 5 to the power 3 into, then this 10 into this t to the power minus 8 we can write as 1 by t to the power 8. Now next steps. 25 into this number t to the power minus 4. This 5 cube we can keep in the numerator, 5 power 3. Then this 10 right here, this 1 by t power 8, this t power 8 we can keep in the numerator like this, t to the power 8 like that. Now next steps. This 5 cube, let's write first like this, into next is t to the power minus 4 into t power 8 by 10. Next is equal to sign (25) into 5 cube into since this is multiply, we have to add these two powers, so t to the power minus 4 plus 8. Then this 10 is here. This 25 and 10 we can divide by 5. 5 times 5 is 25. 5 2 times is 10. Now next, in the denominator that is 2. This is 5, so write 5 into 5 cube is 125 into t to the power. This is minus, this is plus. The sign are different. So if we substitute, we'll get power 4 is equal to sign 2. 125, let us multiply by 5. 5 are 25 to carry. 5 2 times is 10, 11, 12. 5 1 times 5 plus 1 is 6. Then t to the power 4. So we are getting this 625 t to the power 4 by 2. And this is the answer. Next question is Roman number 2. This Roman number 2 is same as Roman number 1. So you try this Roman number 2. Now let us study about use of exponent to express small number in standard form. Standard form of a number, any number that we can write as a decimal number between 1.0 and 10.0 multiplied by a power of 10 is said to be in standard form. Examples of standard form are Roman number 1, 1.6 into 10 power 2, Roman number 2, 3.9 into 10 to the power 5, etc. Sida hai si kano si number amagi standard form si karamba number no hai kanta ngasagi piriba number do akhoi na decimal number oina igani adu ahamba number do 1.0 ka 10.0 ka gi marakta leiba number ohengani adugi number do da akhoi na multiply laga 10 gi power da iba targadi haibati sigi form da sigi number sita si ahamba leiba number si 1.0 amasung 10.0 gi marakta leiba number ni adu gamathangi sina 10 to the power 2 hin lai sumaini iriba mong si number amagi standard form ni haba aduga sitana Roman number 2 si samane ahamba iriba number si 1.0 amasung 10.0 gi marakta leiba number ni aduga mathangi sina 10 gi power da iba into 10 power 5 sumaina iriba number sibu number amagi standard form kawi haba adudi hauji akhoi example ma toreng si example write 4180000 in the standard form. Hauji question thai si sigi piramiba number si standard form da iwaba adudi hauji solution da la si number to ire 4180000 is equal to ngasagi standard form gi ngasagi definition gi matung ina hamba number do 1.0 amasung 10.0 gi marakta leiba number oina igadawni adu itardi hauji state lairamiba number si akoina 1.0 dagi ti sauba 10 dagi ti pikpa ohen gi haitardi hauji decimal point namakani decimal point se akoina state thamba taragadi haibadi 4 ga 1 ga gi marakta state thamba taragadi haibadi sumaina state akoina point number thamba taragadi lagadu sumaina ni sigi number si point si nam taragadi sumai lagtoni 4.180000 sumain lagadabni ado point ki matung da laiba 0 si magi value si yaude aduna sigi 0 mayam si kathat kharaga 4.18 tare si 4.18 kari mo koina point si state number taragadi Hojik sida lairiba point matungda lairiba place masing thini 1 2 3 4 5 6 6 place ni adoi tadi khoina sidaida 0 6 yauba number amana multiply tawni sida 1 thame aduga number of zeros 6 lakani 1 2 3 4 5 6 number ani si multiply tawkanda sigisi sidaida pyramid number si sapchana tani. Now 4.19 is we are writing here the number of 0 is 6, so we can write this number as 10 to the power 6, and this is the answer. 4.18 into 10 to the power 6 in the standard form. Sign it standard form to ini sigisi yani ko bhap tare ko adudi sikhanga di hoji exercise hoba yarni exercise tawrsi. Exercise 11.3 question number. Exercise 12.2 question number 1. Express the following number in the standard form. Hoji question naisi makha tapi number si standard form the ioba Roman 1 si tausi 0.0000000000085 laire sida koina number of zeros si count tausi. Let's count the number of zeros after decimal point. 1 2 3 4 5 6 7 8 9 10 11. Here the number of zeros after decimal point is 10. 1 2 3 4 5 6 7 8 9 10 no 11. Here after decimal point the number of zeros are 11. So now this is the question. Now solution. 0.12345678 9 10 11. Here the number of zeros are 11 and 85. Now is equal to sign. First let's leave this decimal point. So after this decimal point, how many places are there? Let's count. 1 2 3 4 5 6 7 8 9 10 11 12 13 places are there. So in the denominator the number of zero will be 13. 1 2 3 5 6 7 8 9. To write this given number in the standard form, we have to make this number as a number between 1.0 and 10.0. So if we keep this decimal point here like that 8.5, then this is a number in between 1.0 and 10.0. So if decimal point comes here, then from here up to there how many places are there? Let's count. 1 2 3 4 5 6 7 8 9 10 11 12. So here the number of 0 must be 12. 1 2 3 4 5 6 7 8 9 10 11 12. Like this it will come. Next is 8.5. Here the number of zeros is 1 2 3 4 5 6 7 8 9 10 11 12. So we can write this as 10 to the power 12 is equal to sign 8.5. If this 10 to the power 12, if we want to write in the numerator, then we'll keep minus sign in the power like this. 10 to the power minus 12, and this is the answer. Now let's write this Roman number 2 solution. 0. Let's count how many number of zeros. 1 2 3 4 5 6 7 8 9 10 11. 1 2 3 4 5 6 7 8 9 10 11. 942. Now we have to write down this in the standard form. So to write this number in the standard form, first we have to write down a number which is greater than 1.0 and less than 10.0. So to make this number as a number which is greater than 1.0 and 10.0, this decimal point we have to keep here. That means we are going to write down 9.42. If we keep this decimal point here, let's count how many places are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We will get this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The next is 9.42. Here the number of 0 is 12. So we can write as 10 to the power 12 is equal to 9.42. If we want to write this 10 to the power 12 in the numerator, then we will keep minus sign in the power. And this is the answer. See, gyantai ko? Now Roman number 3. Solution 602. Let's count this number. This number of 0, how many zeros? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Now next step. To write this number in the standard form, first we have to write down a number which is greater than 1.0 and less than 10.0. So to make this number a number which is greater than 1.0 and less than 10.0, we have to keep here in between 6 and 0 a decimal point. That means like this. 6.02. Then here the number of 0 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 into 1. Now from this decimal point up to this, how many places are there? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 15 places. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. This will come. The next steps. 6.02. After point, if the last numbers are 0, for these zeros there is no value. So let's leave these zeros. Then into 10 to the power. Here the number of zeros is 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 10 power 15. And this is the answer. See, gyan tare ko, yarni ko. Okay, for today, let's stop here. Okay, all of you, thank you.